Let's start recording on Big Boulevard. Okay, starting from where we left last week, actually, there was something I wanted to show, but we didn't have enough time for that. So we are doing that today. Um just I want to review what we discussed last Tuesday about function templates. We saw that uh, there is a case where you have the same logic. For example, this one for a function, the logic is same, and it is just receiving in this function receiving two variables or objects or whatever of type, and then doing some addition. If it was an integer or double, it was really clear what it was supposed to do. And in terms of class and objects here, we said that we have to define this plus operator, addition operator. We should overload that, and after overloading this template also worked for the objects of type that class where this plus operator is overloaded. And this saved us a lot of time, so we really didn't have to repeat this for every single type, because the logic was same and the difference was in the type of the its input arguments and the output. We just simply said, okay, we just put a placeholder over there for the type, and then keep the rest, and add this caption template, type name, and then what we are the placeholder that we wanted to put for the type. And this placeholder could be anything. Instead of type, we could put anything that we liked here. I can put R and then put R here instead of all of them, and it would work perfectly fine. So we are basically here defining the placeholder that we are putting, instead of we are replacing with that specific type that it was previously there. It was int or double or an object, a class, or whatever. Same, this was for sum, and we saw different examples for sort. For sort, we had one sort function that was sorting some stuff in an array, and a swap function, and the swap function we also turned into template, and this print function we also turned into template. So just a reminder, now this is not a real function. I hope you agree with me that this is not a real function. A real function requires to know what specifically the type is, which we don't know in this case. We just put in a placeholder. And this will lead us to a fact that we will discuss after this, where and how we can take this template out of our main, and what kind of file, if it should be a header file or if it should be a header file and a CPP file. We put signatures in header, so some discussions like that. Just keep in mind that this is not a real function. This is now just a template. Potentially it can turn to a real function if the compiler, like as soon as the compiler knows what the type is, this template can turn to a complete real function, like the functions that we all know in C and C++. In this case, we didn't see any class that had resource all our previous examples were with class that didn't have resource. So here we're going to define a class, and this is the same similar class we used for a couple times before, class name. And in this class name of mine, um, I'm just defining, and here to make things a little bit faster, I'm just trying to copy paste. And here we have an m value, a character pointer m value. Then we have uh, a, a one parameter and default constructor at the same time. Again, just to review why this is both one parameter and default constructor, because we are initializing that one variable to null ptr. We are initializing to something. Anything that you initialize, it can play the role of a default constructor, because in that case you don't need to have this, you don't need to send this name, and this will work perfectly fine. So this is both, because we are initializing that, it is both the one parameter constructor and the default constructor. A rule of three, copy constructor. Again, because we have this default constructor, I can ask, I can postpone everything here, and uh, I can delegate this task of copying to the copy constructors here, copy constructor, and copy assignment. And for the copy assignment now, uh, let's look for the copy assignment. In copy assignment, we first check if we are not copying n to itself, if we are not copying the object to itself. If we are not, then we are deallocating the m value memory and just copying whatever we have in m value of n to our current object's m value and return this. And for the destructor, we just deallocate the allocated memory for m value, and let's skip these. And here what we have for the display, I need to put display. For the display, I put my display here. An insertion operator overload. Insertion operator overload, we have this as usual. I'm using end display in the insertion operator overload, and that's it. Now I want to use this template. I want to use this class. I want to instantiate an object of type this class and use with type sum. For that, I have, well, you based on what we discussed last time, you agree that this will work. Now I have int a and b um, um, initialized to 10 and 20. So using sum, when the compiler sees that a and b are both type integer, then translates the sum to integer. This will work perfectly fine. Then for the double, same thing. This will work perfectly fine. Now this time the type will be replaced with double automatically by the compiler, because we have double, we don't have problem here. Now here I am instantiating objects n and m. of type name. The first one is initialized to Seneca, the second one is initialized to college, and I want to do this sum. Now, I want you to think about it and let me know uh, for the sum, what happens if I run this as it is? Will this work for the name now, considering that sum is this, sum is this, and you already saw how I defined my class name. Class name has this variable, member variable, and the constructor, copy constructor, copy assignment, destructor, display, and insertion operator overload. Now, if I run this, imagine there's no other thing, just up to here. If I run this until sum, will I see a result or not? Uh, uh, I see that there, yeah, let's just start a poll. Okay, now again, repeating the question. The question is, in if I run it until here, so that all the lines down to this name here, everything I want to run everything. Based on this, do you think this will work or I will face an error? Yes or no? Will this work or no? Keep answering, please. This could possibly be one of today's quiz questions, by the way. Not exactly this, but something like this. So think carefully about it. Still, we need more answers. Okay. We see more no's than yeses. And I'm going to ask one of those no people uh, why they think it will not work. Uh, Randomly, who? Like Sebastian. If you're there, please let us know why do you think it will not work? What will be the problem?
Could I see the sum function, please?
Yes, this is the sum function.
Actually, no, I think it would work actually.
So that was a misclick.
Yeah.
Okay. Uh, Thank you. So one other person that said no, I see here. Well, actually, Song Ju. You said no. Why do you think it will not work? Are you there? Mm. Oh, you don't have mic. Okay, let me see. All right, just type because of float. You said because of float. What float? I don't see any float here. This will work. Well, we said that this int and double will work. They don't have any problem. Here, do you see any problem? Do you see any problem here? Consider the name as we defined just now, just 2 minutes ago. We defined name and sum. You know what sum is? Simple. a simple sum function, it should work.
Wait, but do we have an addition operator for the?
We don't have. That's the point. Yes, Sebastian. Thank you so much. That's the point. Um, Excellent. So the point is, the very very important point is, when specific types like integer, like double, like character, like these all these types are very well defined in nature in C++, but which we don't have any problem. So we don't. It's stupid to say, um, for int. It's stupid to say I need to define or overload plus operator. It's already defined for int, for double, for character, for not for character obviously, like for you know what I'm talking about, for float, uh, types like this. But when this type becomes an object of a class that I am defining, and compiler has no idea what that class is, what that object is, unless I define it for the compiler, then that is a dangerous point. You should carefully think about, for that, for the object of that type, in this case type name, if I want to use name here, what should be defined in that class? Here we see that one of them is copy constructor. Why? Because as soon as I put it, I want to send. I want to send here in this line. I want to send n and m. See, you see this line, n and m. Then it will put. Uh, here type a is equal to n. So for this one, it requires to know the copy constructor. So copy constructor must be defined. And also the same thing, it will say type b is equal to m. So for this reason, well, maybe I can comment it. Type a is equal to n. But copy constructor we already have, because this was a class with a resource, and automatically after doing that we just write the rule of three. But what else was required that Sebastian caught in his second try is this operator overload. Now if there is no operator overload plus operator overload in this class, how is the compiler going to take care of this a plus b, right? It is, I think at this point it's very clear what I'm talking about. For every single template, that's why we said we should document each of these templates. Again, reviewing from last session, what could be the documentation for this? The documentation reads like this: for the user, for the person that wants to use your template, it should be your class your class must have one copy constructor, 2 plus operator overload, so that that class can work with this template. We said we had this, and now what I need to add is the uh, this operators. Somehow I should define now how this plus operator is going to work. This is how I have defined this here. Uh, to Now our member function is a string, right? So for that string, what I have defined is a concatenation. Instead of addition of like two integers, this operator plus here works in the form of concatenation. It concatenates the second it concatenates the whatever on the right hand side to the left hand side, and now we have this operator plus, and the compiler, when it reaches here, it knows what to do. And if we want to see what happens in detail, first I create a character pointer temporary, allocate enough characters that can hold uh, the concatenated version of the both uh, m values plus one, because it's a null terminated string. I've used str copy to copy m value in temp, str concatenate to concatenate these two, deallocate m value, copy temp in m value, and return this. This is what I have used. Uh, at this point, if it is clear, you should be able to answer my second question. Now, this will work. Now, again, I want to use that same object of type name, of the same name, same class. I want to use sort function for that. Now, let's see what we need for sort. Uh, so here you can see uh, here n is defined, m is defined. I have defined another s here, and I have put n and m and s in an array, an array of names. And in this array of names, I want to use sort function to sort these and print these. And I'm telling you that I will receive an error here. Why? Let's look at these things. Now, uh, we need um, we need somebody to let us know what we need to, a volunteer to let us know what is missing for for the class name to be compatible with this template sort, which at some point calls the swap, and this is the sort. And in print, actually nothing is happening in print. We're good with that. The only thing we need is probably we need to look at sort and swap. Can somebody tell us what is missing for that class name? Look careful. This is very important to answer this question for yourself, um, because otherwise creating templates and documenting those templates will not be possible. You need to know what exactly a class needs to have to be compatible with your template, and you need to add that documentation to your template. What you see in these two functions that we need to have up there in our class, and without that it will be meaningless for the compiler.
Is it like a for the sort function on line 83, a comparison operator?
Exactly. Thank you, Sebastian. That's exactly correct. When the compiler comes here and wants to compare these two arrays, now these arrays are not just simple int or float or double arrays, right? These are name type arrays. How can a name be compared to another name? Just think about it. we have a complete object of type name. How can a name here in this line be compared to name? These are this one is, we put names in the array, right? So this will be one member of that array of type name, and this is another member of type name. Unless we define this less than operator in our class, this will be meaningless for the compiler, because now how can a compiler figure out if name n is less than name n? It's meaningless. You have to add this meaning there. That's correct, Sebastian. Thank you. And for that reason, I am adding the Boolean operator less than, and simply using str compare for this. Now, if I run, by the way, this is all from our utility files that we have, the util module that we have. Now, uh, I guess this will work perfectly fine. So these were fine. We didn't have any problem with int or double, but in the name, but when we wanted to use some based on the specific requirements of this template, we had to go back and add a plus operator overload to our class. And here, because of the specification, because of the nature, because this less than was used in the sort function, we had to go ahead and overload less than operator in our class. Now it should be good, hopefully. If I run, we see that the same template, now the same template works for an integer. It adds these two, then it adds these two. It works perfectly fine for the double. And for the sum, because we basically use this plus operator to implement a concatenation. Now Seneca and college are concatenated, and in these in this array of type name, because we implemented that less than function uh, in a way that it returned true, based on the comparison of basically in this one, when I implemented this str compare returns a positive value if this if the m value and m value that are being passed there, that this m value has the ASCII code of these characters is higher than the ASCII code of characters of this. Go ahead and check in the str compare. Because that is now implemented here, now we have this kind of sorting. Now, S, Seneca, graduation, and college. So it's in the descending order. Seneca, graduation, and college are sorted, and it works perfectly fine. Now, I have a question. If I want to, well, first let's check if everything is okay until now. Does everything make sense until now? Okay, wonderful. Now, uh, what if I want to change this to a instead of descending order, what if I want to modify my function to sort this in an ascending order? So put college, then graduation, then Seneca here. Wouldn't I go simply here and change this line instead of less than? I can simply say greater than. Huh? What's the big deal? Now, would this work if I change this? Would this work without any change in the class? Yes or no? You guys are smart. Go ahead. Answer, please. What happened to other people? We need more answers. Are you still thinking? Answers. One, two, three. Okay, four people said no, it will not work. And we have plenty of no answers. From no people, Hashmit, you're the first one who said no. Why do you think it won't work?
Professor, we'll have to overload the greater than operator too.
Very good. Exactly. Uh, that's exactly the answer. Now, this is another operator. This is greater than operator that has not been defined in my class. If you want this work, you have to overload this operator as well. This wouldn't be an issue with an integer or float, right? Because these are all already implemented for integer and float, even at the hardware level. In your CPU, there are flags telling you if this integer is greater than this integer or not. There are literally flags implemented in your CPU. So in the very, very hardware level, these are implemented. But this is not the case with objects. So when I do this, then I have to add Mr. or Mrs. that want to use this template. Your class must have greater than operator overload, which we don't want to happen, right? Which we don't want this to happen. So be careful. If we look at this very, very carefully, we can still handle ascending order by just saying this, by adding this, right? Because because changing this to greater than requires implementation of another operator overload. Why not do this? Now for this one, uh, now this should be okay, and we should see this in the ascending order. In the ascending order, yes. See, college, graduation, and Seneca. College, graduation, and Seneca. Uh, just be careful. Here, where is it? Be careful. Here, maybe some people says, okay, now you have to go ahead and overload inversion or this not operator for our function. Why did this work? Why did this work while there is no inversion or not operator overload in my object? Can somebody answer?
Professor, can I give a try?
Yeah, yeah, go ahead.
So basically, the less than operator, is returning a Boolean result,
Mm,
and the not is being applied on a bool.
exactly. Thank you so much, Hashmid. This, the output of this part is a boolean. The output is not an object. Because it's a boolean, then not that boolean is very well defined for the compiler. If it is true, it will be false. If it is false, it will be true. In case the output of this operator overload, this less than operator overload, was again type class, I had to go ahead and define this inversion overload over there. Thank you so much, Ashmit. That's correct. Uh, okay, that's all you wanted to know about using class with the resource with function templates. Is there any question about this? Okay, excellent, excellent. Now, it's very good. Now, it takes us to our second point, second important thing, which is very, very important. And that is, what if I don't want to put these templates? Now, everything is in my main, right? What if I want to take these templates out of my main? Where should I put this? Uh, Keep this in mind, people. It's very important. Now, listen very, very carefully to what I'm saying right now. We don't treat function templates as real functions, as I said like half an hour ago. These are just templates. That's why we don't put the signature in the header file and the implementation in the uh, in the CPP file. We put everything everything that you see here, the implementation, like the template itself, the whole template, and the whole templates, all the templates that you are using in your main, we put everything all together in a header file, and then include that header file in our main file or wherever that we want to use that template. The reason is actually because of the because how the compilers work. The compiler, I have a slide actually for you. Let me open up this for you. This is how the compiler works. The compiler first, now in this example, I have three CPP files. Uh, the first CPP uses its own header. The second one uses the second header file. The third one uses both its own header file, which is 3.header, and also uses the second one's header. And this is my main. I have included header 1, header 2, and header 3, which has that header 2. You see, now header 2 is used 2 times. That's why we use that if not defined, blah blah, then define blah blah. If you don't do that, this header file will be included 2 times because it's literally being added to my main 2 times, right? But apart from that, well, how compiler works is like this. Compiler becomes, every time that wants to compile one module, it becomes completely blind to other modules. So to create the object file of first module using the header file and the CPP file, at that time there is no module 2, module 3, and main. It just compiles this like this separately, compiles this separately, compiles this separately, and compiles this separately. And at the end of this compilation procedure, we have 4 object files. 3 of them are for the modules, 1 of them is for the main. Then the linker comes to play. Now the linker carefully searches the files and tries to replace things that are defined in different modules. For instance, now if I have, obviously you have promised something in each of these header files, right? It comes to your promise here, looks for your promise in header 1, sees, okay, now my promise should be something here, then it replaces this in my main file. This is true, and this can work perfectly fine. The linker can find the function perfectly fine, as we have seen so far, if that function is a real function. If you promise some real function here, and the linker in the objects, then the linker looks at these objects and wants to replace that function, that promised function here, from the CPP file here, then fine, it will find that real function. It knows it's returning what is the type of its input argument. Everything is normal, life is good. It replaces it here, and it works as you have seen since the beginning of the semester until now. But it will not work with the template, because with the template, now the confusion is, now for this function, am I going to replace the what kind of function has been promised here? This is just a template, and for this template, I don't know what kind of logic is going to be implemented, what is the type, and so many confusing things for the compiler. As a result, what you need to do is this. Is this. So if I close this solution, what we need to do for templates, to take the template out of my main. See, I have taken this main out. This is just my class, the same class defined. Well, template sum is here. We can add that here. Swap sort is here, so let me also add this template sum. So let's run this. With this one, if you can see, everything is same. What I have done is just I have taken everything, all the template, and I have not separated that to signature and implementation. I have just put everything in a header file, templates header file. Look, now the files that I have here is main.cpp, utils.cpp, templates.header, and utils.header. And that's enough for this to work. And if I run this, it will run the exact same way that it was working. And let's take some there too. Where's some? Here. Let's take this to there. Let's put it here. Okay. And if I run, this will be the same thing. So keep that in mind. In workshop 10 and in future real projects that you will be doing, templates are very important things because they make work significantly faster. If you want to have a file with you, just like in the future, you might have templates file with you in addition to utils file. Use it as a toolbox. So to use that toolbox, you need to have only one header file that includes all the templates with the implementation completely, like the complete function with signature implementation and everything, and the documentation. So if somebody opens this and wants to know what kind of classes are compatible with your template, can see the document. So you put the document here as well, and that will be enough to work. Is this clear? Okay, very good. So take home message, templates do not have .cpp file. Templates only have header file, and you put every single thing in that header file. That's the take home message. Very good. Now, we are done with function templates actually at this point. And I want to do something very interesting. We want to define a class. Now, so far uh, we had functions as template. We turn functions into templates. And now we want to uh, we want to we want to convert. We want to write a class. Write a class that is an array class. So I want to keep my things in it, and I want this class array be something of use for me, and this will allow me to systematically deal with arrays. Um, let's first start with an array of specific type, and for that I'm using this a double pointer M array, which is the pointer to my double type array, and I am also defining another member variable M size that is the size of my array. And the constructor for this class, I have implemented it like this. Again, this is both the one parameter and the default constructor because I have defaulted this to 10, and also I'm actually doing this if this size, because uh, it might like kind of semi foolproofing thingy here. If the size is 0, I don't want that 0 to be entered to my size. If that size is 0, I set it to a default value 10. Otherwise, I assign that 0 to my M size. And for the M array, now I allocate a new place in the memory with the size. We know that int or double arrays are not null terminated, right? That's why I have the size there. Rule of 3. Now, the first thing is rule of 3 copy constructor. Now I put copy constructor here, And again, in the copy constructor, I want everything be done in my copy assignment, and then the copy assignment. Copy assignment. How does this copy assignment work? Now let's take a closer look. In this copy assignment, uh, again, I check that I make sure I'm not copying the same thing in the same thing. I just say m size equal to a dot m size, which is the size of the array. Deallocate the m array first. Why? Because I want to create a new piece of memory with the size of what has been stored in A, and allocate that to let m array point to this place now. And then, because this is an array, you need to copy everything that is in m size to what is in m array in a for loop. Guys, I thought I have commented these because if you want to review later, it will make your job very easy. Uh, so I will just upload these as it is. But uh, I guess maybe not. This might not seem very familiar to you. Uh, is there any problem? And don't be shy. There are people that after 2 3 months or maybe like 1 year coding in C or C++ still trying to avoid pointers uh, because they are difficult concept they think, or maybe it really is. But anyways, I'm talking about line 31. Is there any question mark for you about line 31, about what I am doing there? Is there any question mark? Okay, makes sense. Uh, Still, I think there is still people that are not answering. Maybe they're not here, but I'm assuming they are. Um, I'm assuming we have some issues with this, so I'm just trying to explain. Listen, um, what I am doing here. What is the M array? M array is the address of the first location of this double array of mine that I have allocated here, right? This returns an address here and says, okay, M array is now is starting from location 100 in the memory, in the RAM. Okay, and this guy is the a.m array is the address of the physical memory, the first place of that array that has already been returned when A was being created. So this is also an address. So this is 300 address, like location 300 in the memory. For example, these are just nonsense, right? I'm just giving you tangible examples. Now, in this for loop, I'm changing I, and I'm saying, okay, and I know I is an integer, right? I is an integer. I'm putting some stuff in here, and I'm saying, okay, now I want you to go ahead and increment this address by this, and put, we said that if I put another asterisk, m array is already m array where is it? M array is already a pointer. So by doing this, this I is being added to the address of this memory every time. 0, 1, 2, 3 is being added to this memory locations, and a double is being stored in that memory location. And by putting the second asterisk, I am changing this address. Now this inside the parenthesis is the address world, and by putting the second asterisk, because it already had one, I am making this the content world. So I'm saying what you see in memory location this, please copy that to memory location this. And that's how it works. I hope it's clear. So this way, basically, it's a very efficient and powerful way of implementing this. Probably the fastest way to do this. There is no need for operator overload. You would do it this way, like what? You would do it with the m array I is equal to a dot m array I, right? But this way you had to overload this index operator, and by this I'm avoiding overloading this. And also we're reviewing a little bit about pointers, stuff like that. I hope it's clear now. This is what I did. Now the next line is the destructor. Now I am using this destructor here. In the destructor, just deallocate the m array, and for the queries, I want to have two queries, one query for the size, another query for the array itself. And in the array, I want to return m array. In the size, I want to return m size. These are straightforward. And here, I come down here and forget about this index operator, and the helper, this one will be this helper will be this helper to print, and this is what I have in the main. So in the print again, what I am doing is one by one I'm going ahead, and one by one I am printing the content of this get m a dot get array. Basically will return the m array, right? And that m array is the address. I will add to that address, so it will basically enable us to move from one block to another one. And this asterisk, the second asterisk, will make it the content world. So by this, it's as if I'm one by one moving through this array. By increasing this I, it's increasing the address, and every time it's printing the content of that thing in the array. And here, if I write print array blah blah blah, okay, let's see if this works. I wouldn't be surprised if it didn't. Okay, it worked. So now what I am doing after all these definitions I have here in the main, let me close this. In the main, I am creating a new array A, size 8, and assigning in every, again, the content of this, I'm making 0.1 plus I. So whatever I is at 0.1, to the, sorry, 0.1 multiplied by I, so the content will be 0, 0.1, 0.2, 0.3 until 0.8, 0.7. We start from 0, and then this will print. Then I'm sending this A, and I'm sending the size of that array. That's why we see this 0, 0.1, 0.2, blah, 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 blah. And this is a class of type array. Now, I can systematically come here and define a class of type array of type double in this case. Is this okay so far? Very good. Very good. Now, Alfred, any question? So now, somebody to make it nice, you see, it works without index operator overload because we use pointers. But if somebody says, okay, let's also have the index operator overload uh, and see uh, and see that too, say, okay, let's practice implementing the index operator as well. And also, what happens if somebody comes here and says A15, for example, this is an example that I have here. A15 is equal to 6.8, considering that um I defined an array of 8, of size 8. Would this work or not? First of all, it is giving us error because it doesn't recognize this index operator. So let's go about here and implement the index operator. So I want to implement this index operator. This is how I implement it. Operator, operator, and then the rest of the thing straightforward. Just this operator requires an index, right? You put an index in it, and if that index is greater or equal than m size that we have, it means it requires, the array requires to be resized. You don't have, the size of the array is smaller than the index, as is the case with our example. This is 15, this is 8. And uh, and else, if this didn't happen, I don't want to resize, and I just want to show the, if this operator means this, index operator means this, show the content of m array plus index minus 1. So if we say index is 3, right? Because we start from 0, we show the content of 0, 1, 2. We show the content of what's in 2. And this has to be added to the initial address of the array. Otherwise, in the memory, it will not be found. For the resize, I have another function here for the resize. Now, how am I going to resize this? For the resize, if that index of mine is 0 by mistake, foolproofing again, I make it a default value, define a template of type double, and do the rest of the thing as it's straightforward. Now that temp, you allocate a new memory, then you you do this in the for loop, you copy everything there, you delete, you deallocate the M array, you copy that, and finally you put M size as the new index here. This is how you resize this. And in this way, we can, if I come here and say A15 is equal to 6.8, and then say I want to show A15, this will be possible, and we will see the 6.8 over there. Now, a very good question that actually wakes up those people who are sleeping, maybe, hopefully not. What will I see now? This one, this print, we said that this print accepts this array, and prints the size. Now, what will be the output here? Will I see 0, 0.0, 0.1, blah blah, up to 0 point something? What will be the output? Can somebody say, answer this question? Say what he or she thinks the output will be? See, we put in array A, we had initially we created an array of size 8. We put 0 up to 0.7 in all these 8 positions, 0, 0.1, 0 up to 0.7. Then we print that, and then we put this A15. We put 6.8 because this 15 was greater than 8. The in this one, in this index operator, because the 15 was greater than 8, definitely resize has been done, and in this resize we just resize the we just make it bigger, just made this double bigger, and what we copied was for the M size. This M size was the older M size. M size has not been equal to index here yet. So this is the previous one. So we copied 8 of those here, and returning here, and then it returned this value, which was 6.8. So based on this, what do you think I will see after 0.7? From 0, 0.1, 0.2 up to 0.7, we know this will be the output. But what will be after that 0.7? The fact that nobody is answering actually is a good thing, because we have not initialized those in our function. It will be garbage, whatever is already in the memory, unless it reaches to A15. So after the 0.7, we will see garbage until we reach to 15, which will be that. Uh, Sorry, this was my misclick. Yeah, after this we will see um in the for the array number 15, we will see the value that has been assigned. So why am I doing this? Why am I showing this? Because I want you to know and to remember. Did we face any error? No, it's still running. Because I want to show you Look, this is 0, 0.1 up to 0.7, then garbage, 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 and 6.8. Because I want to show you pointers are not a solid thing. They are just pointers, as the name shows, pointers to some specific address values in the memory. So these these are just whatever left in my memory, and these are interpreted to double, and the double equivalent of what zeros and ones that was in the memory, because nobody initialized them to anything, is interpreted to this. But 6.8 is A15, which I initialized that to 6.8, and that's why we see that 6.8. So be careful with these pointers. I intentionally didn't initialize these. You can, as a practice at home, you can go ahead and fix this problem by initializing, somehow figuring out how you can initialize the array that you are creating to avoid showing garbage, and at least we show like zeros maybe, or 0.0, something like that. Okay, very good. Any questions so far? Okay, excellent. Now, let's make it move it a little fast so that we can wrap up this class term. Now, the purpose of defining this double class is to create uh, a template class. What if, now I'm closing this, what if I want to use this class array and create an integer array instead of double? Should I go ahead and create everything from scratch? Of course not. We can convert this class to a template, and the rules are things that we already know. There are the first step. What is the first step? Can somebody tell me what the first step is to, now I want to convert this temp temp sorry template template type name type. Okay, I want to convert this array, which is double, to a template. What is the first step that I should do? Can somebody say? You should know it from our last session. What is it? What is the first step in converting this array of doubles to a uh, a template of arrays that can be used with other types as well, like integer, for instance? Nobody remember? Okay, yeah,
Uses double stuff to type.
exactly. The first step was to go ahead and find wherever you have type double, change that to type. So let's do that. Change.
Hamid, one question.
Yeah,
Is there a difference between putting like inside the brackets type name type or class type? Because I saw in the documentation that you can also put class.
where here? I didn't get here. You say class?
Yeah. Yeah.
Type name? No. By type name, we are defining the placeholder for the type that we want to put there.
Oh, okay.
Yeah, you use type name always.
Okay, right. Thank you.
No problem. And this double I changed, and then change the other double. Where do I see double? Another one is here. Another one is double here. Please tell me if I missed any of these doubles. Type double, double, here double, double here, and anything here? Yes, here I see double. I see double. I see double. Is there any other double? There is no other double. And this is it. Okay. Oh, we changed all the doubles to type, but still we have some error. What is that error? That error is a crucial error. That error is here. Look at this. Can somebody tell me what they think the problem is with this line? Now, I have a template. There is no, it's not type specific. It's a template. It doesn't know what type it is. And the compiler must guess what type of array I am creating using this line. Is this possible for the compiler to guess what type of array I am creating? Int or double or float or whatever. Is it possible for the compiler to guess? Yes or no? Please keep answering. We created a class of type template, and the compiler is supposed to guess what type of array I am creating just by looking at this line. Probably because of the tone of my question, you could guess the answer is no, but definitely you know that the answer is also no. How could possibly the compiler know if this is going to be an array of integers or doubles or what? Apples or oranges or what? It's not possible. That's why, because we don't have enough time, I'm just showing you the correct way of this, and you can investigate it and see. There is another thing involved with this. Sorry, let me open this one. This is in addition to that, we need another step, which is adding. Not only you have to, for classes, there is one more step involved. Not only you have to change all those doubles to type, but also to define what type of array you are creating here, you have to put this class. Oh, maybe Sebastian, your question was about this. I don't know. Class and then that type. You put this type to define what type of array we are creating, and then add this type as well. Add this type here, just like this. Add this type. Type. You see, if this type was double, this should also be double. So we add this type wherever we see the array class name, except for these three places: name of constructors, name of destructors, and the class name right after the template. Right after the template, there's this class name. You leave it alone. You don't touch this. The next thing is a constructor. Again, you don't touch this. But after this, again, this is a copy constructor. You don't touch this. But after this, wherever you see array, you put type. Why? Because we want to make it clear for the compiler that what type of this that type then replaces with this double. Now if you say here double, the compiler knows what type it should be created, and this is the second step when you are creating class templates. And you do this wherever after that you see array, you put this type type in all of them, type, except for this is a destructor. Now you don't put it. Just three exceptions: constructor, destructor, and copy constructor of course is included, and the class name, this one, right after the template. And if you go and check, I have added this type wherever there is this array. Even here in the print, because it's also a template, in the print you put array of this type, and then this will work. And then we are able to create array of double type, and then come down here and create array of int type using the exact same template. And this worked perfectly fine for the array of double and for the array of integer. And take home message: classes can be converted into template as we converted a double array to a template. And with that, uh, we have to do two things. One, replace the type, for instance double, that we had here with your type placeholder, whatever it is. In this case it is type, so I replace double with type. The second step, add that type thingy, this type, in front of the class name, except for constructors, destructors, and the class name right after the template. This way we can make a class template. So this basically summarizes everything about templates so far. So three take-home messages. You know how to make functions, function template, and deal with class with resources when you are passing them to a template. You know how to take out the templates and put a separate header file. They don't come in a CPP file. And you know how to convert a class to a template using these two steps. Um, and this actually summarizes our template. There is no more discussion, nothing left. You know every single thing to do all your workshops and all the milestone and everything. Next time we will have a short discussion about polymorphism and uh, a little bit about the final assessment. And the week after that you will be free. We will not have any lecture, but I will be available as usual. If you have any questions, you can post them to me on Teams, and this will be our thing in public chat. Please quickly, if there is any question, you need to tell it with this. Yes, Sebastian. Uh, is that a question, Sebastian, or anybody else? Because your quiz will start in 3 minutes, I will just answer quick questions. Please review this thing at home, but with all the things that you have now, it will be easy to grasp, and you just need to practice later. Um, Where can I find the notes of templates? If I haven't put notes. I will put. I will check if I haven't put notes of template. I will do it right after the class. What else? Okay, thank you everybody. So your quiz will start in 3 minutes. Good luck with everything. We don't have any new material, so this is a good news. There is no new material from now on. Everything is known now. You know everything. Congratulations about that, and The rest is just practicing things and probably take a look at the notes. We'll see you for a short class on Thursday.
Thank you very much, Professor.
Thank you. Take care.